let's talk about the MAX40200. It's a 1 amp Ideal Diode. It comes in a SOT23 package, and it's a little IC circuit. We're going to use it for ORing, or diode OR circuit, OR logic, and it's used to isolate 2 or more voltage sources. Now we can do the same thing with a couple diodes. If you had the voltage on this diode was greater than the voltage on this diode, it would reverse bias this one and no current would flow here. And in the opposite direction, if this has more voltage than this one, it would reverse bias this diode and no current would flow through there. Now the disadvantages to these diodes are, if you use regular diodes, are about 0.7 volt drop across there, and the Schottky diodes have about 0.3 volts drop. And on those Schottkys, especially them, they're leaky, so current's going to flow back into your battery pack here. And since I'm using non-rechargeable batteries, I don't want any current going back in there wrecking the batteries. So this Ideal Diode here, it has the voltage drop is less than about 43 milliamps at a half an amp, and the reverse bias leakage current coming back to the batteries is only 70 nanoamps, and the low quiescent current, so sitting here in standby, it's only going to draw about 7 microamps off of the battery pack there. So I have the system set up here. I've got my meter on there. Can we see that? Yeah, we can see that the I'm not drawing any current through there right now. 7 microamps or so. I'm going to turn off the power, and I have 0.33 amps on the on this circuit here now, coming off the batteries here, and this hasn't changed. I have a DC to DC converter just to keep this at 5 volts at all times, instead of being at 4 volts. So turn the power back on, and the current on the batteries goes away. They're just in standby. Now, when I first did it, I had 5 volts on here, and I had 4.5 volts down here. But coming out of here, I have just a standard diode in there, so I'm dropping 0.7 volts across here. So it wasn't working. I was reverse biasing this diode, and it was on the battery pack all the time. So I'm putting 5.7 volts up here, and it's working fine that way. Now, I think what I'm going to do in the future is use 2 of these MAX40200s, and I won't have that problem anymore. I can use a 5 volt supply here, and then this battery pack down here. Now the battery pack, it should last a long time. The battery life, battery life is equal to capacity in milliamp hours divided by the load in milliamps, and we're going to times it by 70% just to have a little fudge factor in there. So these batteries they're 2,000 milliamp hour batteries. They're in series, but the milliamps keep the same. This should be an H there, milliamp hours, and we divide that by our 0.007 milliamps times the 70%, and it comes up to 200,000 hours. That's about 8,000 days. So this battery pack should last a long time, and it should be a nice little battery backup for a little transmitter that I have. Anyway, that's the MAX40200 Ideal Diode. Thank you.